Christian F. Domingo again from BSE 3G, and I will be discussing a problem under the subject dynamics of rigid body. So this problem is about the instantaneous center of zero velocity. So this is the problem. The wheel rolls to the right without slipping with its center O, having a velocity VO is equal to 3 meters per second. Locate the instantaneous center of zero velocity and use it to find the velocity of point A for the position indicated. So this problem or this figure is just like my previous video. So in this one, I draw a wheel which has a 0.3 meter radius, and the velocity of its center O is 3 meters per second, and we are required to calculate the velocity of A in an instant, which the line AO gives a 30-degree angle to the horizontal axis. So another information, our distance from point O to point A is 0.2 meters. So first we are required to calculate the or locate the instantaneous center of zero velocity. So here I have a point here which is tangent to the our wheel. This point is also a point from our horizontal path, so or this one, as the wheel roll, there is a point in which it will be tangent to that line, and as I said, this is that one, this is that point, and I'll draw a point or a broken line or an imaginary line from this point to the point O, and also a line from this point to point A. So first, where is the instantaneous center of zero velocity? So this point is already that center. Why? I name this as 0 anyway. Why? Because as the problem said, the wheel rolls to the right without slipping, and without slipping means that our tangent point is the point where the instantaneous center of zero velocity ay nakalagay. So as I said, I draw a broken line, an imaginary line, for us to solve the line AZ, which we will be using to calculate the velocity at A, which is also A required for us. So calculating the line AZ, so this is that one, this is the point A, and this is the point Z. This is our point O. That, and the distance from A to O is 0.2 meters, as I said earlier. 0.2 meters. The distance from O to Z is also equal to the radius of our wheel. So this is 0.3 meters. Then this angle is 120 degrees. Why? Because as we know, this one is a 90 degrees, a right angle. or in the position. So adding those two, 30 plus 90 yields to 120 degrees. So computing to A to Z, this is not a right triangle, so we will be computing it by the use of sine law or cosine law. In this situation, we are given two sides and one adjacent angle, so we will be using the cosine law. Our cosine law, so our A to Z line is squared equal to the square of the line OZ, so 0.3 square, plus the square of the line OA, or 0.2 square, minus twice the line OZ, 0.3, multiplied by line OA, so I'll continue writing here, so 0.2 multiplied by the cosine of the adjacent angle, or cosine 120 degrees. So computing for our A to Z, AZ line, it is equal to 0.3 square plus 0.2 square minus 2 times 0.3 times 0.2 times cosine of 120. So this is the line AZ is equal to the square root of 0.19. And as I said earlier, we will be using this to calculate the velocity of A. So here, as I said in my last video, our point O, or our point A rather, is giving a circular path as our wheel rotates or rolls. So this is that path as our wheel rolls, our A also rolls. So it rolls like this one. Then giving it has a curved path, therefore we can calculate its velocity, but not at point O, but at point Z. So calculating the velocity of A at point Z, so our velocity of A is equal to the radius times the angular velocity. So we don't have angular velocity yet, and we will calculate it later. But first, our R is also equal to line A to Z, right? Because as I said, I'll use the point Z to calculate the velocity A. So calculating it, imagine this is our point. So imagine our A will be ay gagawa siya ng path na ganyan as our wheel rolls. Pero itong point Z natin ay hindi gagalaw. So ganyan siya. Mayroon tayong path na nakapaganon. So burahin ko lang to para mas makita natin. So ito yung path na yun. Itong R nito ay ito. So nasabi ko na, yung R natin is yung line AZ. So R is also equal to line AZ multiplied by angular velocity. We don't have value for angular velocity yet, so we calculate for our angular velocity. velocity. Gagamitin natin na para makalculate yun ay yung ating radius ng wheel tsaka yung velocity niya. So, V is equal to R times omega or angular velocity. And it is also by computing the omega is equal to V over R. Substituting the values, our angular velocity now is equal to the V, which is 3 meters per second, divided by R, which is 0.3 meters. So cancel this meter units. This one will yield to 10 rad per second. So we now have a value for our angular velocity. We can now calculate our VA or our velocity of A. So VA is equal to AZ, line AZ multiplied by angular velocity. So our line AZ is equal to square root of 19. So square root of 19 multiplied by angular velocity, which is 10 rad per second. Therefore, our velocity of A now is square root of 19.19 times 10 is 4.3588 or simply 4.36 meters per second. And this is also the value that I get in my previous video using relative motion of velocity. So that's it.